So in question 1 of this paper, we've been given the graph of y is equal to x squared minus 9, and we've been asked to find the area of the shaded region, circling our answer. So we know that essentially we have to just go ahead and complete the area under the curve between 0 and 3. And this would be of x squared minus 9 dx. This just becomes x cubed by 3 minus 9x between 3 and 0. And if you go ahead and calculate this, essentially what you get is 27 by 3 minus 9 into 3. And this is just equal to 9 minus 27, which is equal to minus 18. Now, this question is a tricky one. Why? Because although your answer comes out as minus 18, the answer is actually positive 18. And that is because the reason that this is negative is because the area under the curve is below the x-axis. So in order to find the actual area of the shaded region, you'd have to take the modulus of this answer, because of course area cannot be negative. So that's why your answer is positive 18. So that is question 1. So now in question 2, we have a wooden frame that is to be made to support some garden decking. The frame is to be in the shape of a sector of a circle, and the sector OAB is shown in the diagram with a wooden plank AC added to the frame for strength. Now OA makes an angle theta with OB. Using this, we have to show in the A part of question 2 that the exact value of sine theta is as shown. So to do this, what we have to do is use the cosine rule. So our cosine rule essentially states that 6 squared would be equal to 5 squared plus 3 squared minus 2 into 5 into 3 into cos theta. If we go ahead and isolate cos theta, we essentially get cos theta is equal to 5 squared plus 3 squared minus 6 squared upon 2 into 5 into 3. And this would thus be equal to minus 1 upon 15 if you go ahead and put this to your calculator. So now that we have the value of cos theta is equal to minus 1 upon 15, we can go ahead and use the identity that sine square theta is equal to 1 minus cos square theta. And so sine theta would be equal to the square root of 1 minus cos square theta. And if we know that, then essentially we know that sine theta would be equal to the square root of 1 minus 1 upon 15 squared. Go and put this into calculator, and you will indeed find that sine theta is equal to 4 root 14 upon 15, hence showing what is needing to be shown. Now in part B, we've been asked to write down the value of theta in radians to 3 significant figures. So we know that cos theta is equal to minus 1 upon 15. And if you go ahead and use our cos inverse, we know that theta would thus be equal to 1.638. And to 3 significant figures, this is 1.64. Finally, we've been asked to find the area of the garden that will be covered by the decking. So essentially, we just have to find the area of this sector. And we know that the area of a sector is just equal to half r squared theta, where we know that r is equal to 5 meters and theta is what we found in the previous part, which is 1.64. So go ahead and put that into calculator, you get half times 5 squared times 1.64. And if you put that into calculator, you should get the value of 20.5 meters squared. So in question 3, we've been given a circular ornamental garden pond of radius 2 meters, which has weed starting to grow and cover its surface. As the weed grows, it covers an area of a square meters. A simple model assumes that the weed grows so that the rate of increase of its area is proportional to A. And in 3A, we've been asked to show that the area covered by the weed can be modeled by A is equal to B times e to the power kt, where B and K are constants and T is the time and days since the weed was first noticed. So just looking at the fact that the rate of increase in its area is proportional to A, we know that dA upon dt would be equal to Ka. Okay, and why is this? Well, that's because dA upon dt is proportional to A. So essentially what I've done is substituted the value of the constant K in for the proportionality sign. Okay, so just going to erase this quickly. Okay, so now that we have this, we can go ahead and split this equation, and essentially we get that 1 upon A dA is equal to K dt. Now, what we can do is integrate both sides, and essentially we get ln A is equal to kt plus c. And we can go ahead and just take the natural log, put both sides of the equation to the power of e, and essentially we would get A is equal to e to the power kt plus c. And we can write kt plus c, e to the power kt plus c as the following, where A is equal to e times kt times e to the power c. And here we can let e to the power c equal b, and so A would be equal to b e to the power kt, hence solving this question. For the B part of the third question, it's been said that when it was first noticed, the weed covered an area of 0.25 meters squared. 20 days later, the weed covered an area of 0.5 meters squared. And the first part of the B question, we need to state the value of B. So let's go ahead and use the first bit of information here, the fact that the weed covered an area of 0.25 meters squared. So if we substitute that in, basically, we know that at time t is equal to 0, A was equal to 0.25. So our equation above was A is equal to B e to the power kt. So we know that A is equal to B e to the power kt. If I substitute t is equal to 0, this e term becomes 1. So essentially, I have 0.25 is equal to B times e to the power 0. And so B is equal to 0.25. Now, for the second part of the B part of question 3, we've been asked to show that the model for the area covered by the weed can be written as follows. So currently we have that A is equal to 1 by 4 e to the power kt. And it's been given that 20 days later, the weed was covered by an area of 0.5 meters, which means that at t is equal to 20, A was equal to 0.5. So I can go ahead and sub those values in to help find the value of K. So essentially 0.5 would be equal to 1 by 4 e to the power 20K. Now if I go ahead and try and solve for K, essentially I get 2 is equal to e to the power 20K. Take ln on both sides, I get ln 2 is equal to 20K, and so K is equal to ln 2 by 20. Okay, now that I have this, I can sub this back into the equation. So I have A is finally equal to 1 by 4 e to the power ln 2 by 20t. So now what I can do here is simplify this further. So I know that A would be equal to 1 by 4, and e to the power ln upon 20t can be rewritten as e to the power ln 2 times t by 20 on its power, because then the powers will just multiply and result in the big fraction we had before. And we know that e to the power ln 2 is just equal to 2. So essentially A would be equal to 1 by 4 times 2 to the power t by 20. 1 by 4 can be written as 2 to the power minus 2. So A is equal to 2 to the power minus 2 times 2 to the power t by 20. And we know when two indices are multiplied together with the same base, and essentially the powers just add up. So we know that A is equal to 2 times t to the power 20 minus 2, as stated in the equation. So for 3b3, we've been asked how many days would it take for the weed to cover half of the surface of the pond. So the surface of the pond is just equal to pi r squared. We know the r is equal to 2. So essentially, we know that the area of the pond would be equal to 4 pi. So to cover half of its surface, it would mean that you have to cover 2 pi of area. So essentially, we need to find what t is when A is equal to 2 pi. So we can go ahead and substitute this value in. So we know that 2 pi would be equal to 2 to the power t by 20 minus 2. Go ahead and take the ln on both sides. So we know that we have ln of 2 pi, and this is equal to t by 20 minus 2 times ln 2. Or we have to just rearrange where we have ln of 2 pi upon ln of 2. This would be equal to t by 20 minus 2. ln of 2 pi by ln 2 plus 2 times by 20 would just be equal to t. And if you put this into your calculator, you will get the value of 93.03 days. Now, in question 3C, we've been asked to state one limitation of this model. And I guess the biggest limitation is the fact that the growth of the weed is not limited. But since the area of the surf or area of the pond is limited, this model has that limitation. So essentially, we know that the area of the pond is limited to 4 pi. However, model suggests unrestricted growth of weed. And that should be enough to get you that 1 mark. So now in question 3D, we've been asked to suggest one refinement that could be made to improve the model. And let's just build upon the limitation that we went for in the fact that the model suggests unrestricted growth of weed. So maybe just introducing a limiting factor on the growth would be sufficient. And that should be question 3. So in this question, we've been told that this integral here can be written in the form of p ln 2 plus q, where p and q are rational numbers, and we've been asked to find p and q. So essentially what we have to do is just solve for this integral. Now to do this, we have to use integration by parts, and the integration by parts formula is just the following, where the integral of u dv is equal to uv minus the integral of v du. So if I have the integral of x cubed ln of 2x dx, then I have to go ahead and choose my values for u, v, du, and dv. So here I'm going to take the value of u as equal to ln of 2x, as that's the sort of more daunting part of this equation. And if that's the case, then du would just be its differential, which would be 1 upon x. dv would hence be equal to x cubed. And as such, v would be equal to x to the 4 by 4, which is the integration of x cubed. So now that I have my 4 values, I go ahead and substitute those into the equation of IBP. So essentially we have the integral of x cubed ln 2x dx would be equal to u times v, which is just ln of 2x times v, which is x to the 4 by 4, minus the integral of v, which is x to the 4 by 4 times du, which is 1 upon x. This can be simplified down to ln of 2x times x to the 4 by 4 minus the integral with 1 to the 4 outside of x cubed. Now go ahead and solve this integral. I get ln of 2x times x to the 4 by 4 minus x to the 4 by 16. Okay, so we have successfully shown that this is equal to ln 2x times x cubed integral. Now we have to find this integral between the limits of 2 and 1. So if I add the limits in, so essentially this just looks like this. And I can go ahead and substitute the values in. So essentially what this would look like is ln of 2 times 2, which is 4, times 2 to the 4 by 4, which is just 2 to the 2, which is just, again, 4, minus 2 to the 4 upon 16, which is just 1. Take away ln of 2 times 1 to the 4, which is just upon 4, minus 1 upon 16. Okay, so now that I have this, ln4 can be rewritten as, so, okay, I'm going to first simplify this. So we have 4 ln4 minus 1 minus ln2 by 4 plus 1 upon 16. ln4 can be written as ln2 to the power 2. So this becomes 8 ln2 minus 1 minus ln2 by 4 plus 1 upon 16. And then I can simplify this down. So 8 minus a quarter is going to be 31 by 4 ln2, and then minus 1 plus a 16th is just 15 sixteenths. So, or minus 15 sixteenths. So this is just going to be minus 15 upon 16. So hence we have shown that P is equal to 31 by 4, and Q is equal to minus 15 upon 16. Solving this question. So for question 5a, we've been asked to find the first 3 terms in ascending powers of x in the binomial expansion of 1 plus 6x to the third. So this is just going to be as follows. So 1 plus 6x to the power a third can be approximated to 1 plus n, which is 3 times b, which is 6x, plus n times n minus 1 upon 2 factorial times b squared, which is just 6x whole squared. Go ahead and simplify this. We get 1 plus 2x minus 4x squared. Hence solving this question. Now, for question 5b, we've been asked to use the result from part A to obtain an approximation to the Q root of 1.18, giving our answer to 4 decimal places. Now, in this case, we know that 1.18 would be equal to 1 plus 6x. So go ahead and put that into the equation. So we know that 1 plus 6x would be equal to 1.18. And to find x, we know that 6x would be thus equal to 0.18. And then x would be equal to 0.03. So we know what x is. Essentially, we know what our expansion is as well. So we can go ahead and substitute x equals 0.03 into our expansion. So essentially, what this looks like is 1.18 to the cube root is equal to 1 plus 2 into 0.03 minus 4 into 0.03 squared. Put this into your calculator, you will find the answer of 1.0564. So in question 5c, we've been asked to explain why substituting x is equal to half into our answer does not lead to a valid approximation for the Q root of 4. Well, this is simply because our approximation is only valid for the modulus of x being less than 1 by 6. And since a half is not within that constraint, it's not applicable. And hence that's our answer. So for question 6, we've been asked to find the value of this integral, expressing our answer in the form of m ln 2 plus n ln 3, where m and n are integers. Now, just looking at this equation, we know that we can split this into 2 partial fractions. So to do that, we have to factorize the denominator. And to do that, just put this into your calculator, and you should find that this equation, 6x plus 1 upon, turns into 6x plus 1 upon 3x minus 2 times 2x minus 1. So that's this equation factorized. So this is obviously in the form of a upon 3x minus 2 plus b upon 2x minus 1. So let's go ahead and solve for this. So we know, just looking at this, that a times 2x minus 1 plus b times 3x minus 2 would equal the numerator of this fraction, which is just 6x plus 1. And I knew this because I cross-multiplied the fractions here, and I know that the denominator here would be the same as the denominator here. So I haven't gone ahead and compared the denominator. All I'm going to do is compare the numerator, and I can expand here to get 2ax minus a plus 3bx minus 2b is equal to 6x plus 1. This gives me two equations. Firstly, for the coefficients of a, where 2a plus 3b would be equal to 6. And finally, a minus 2b would be equal to 1. Go ahead and pop this simultaneous equation into your calculator. You will find that a is equal to 15 and b is equal to minus 8. That thus means that this integral has changed into the form of the integral of 1 to 2 of 15 by 3x minus 2 minus 8 upon 2x minus 1 dx. So we can go ahead and split this integral. So we have essentially the 15 on the outside, the integral of 1 to 2 of 1 upon 3x minus 2 minus the integral of 1 to 2 with 8 on the outside of 1 upon 2x minus 1. And essentially this gives me 15 on the outside and 1 upon 3 ln of 3x minus 2 between the range of 2 and 1 minus 8 on the outside and 1 upon 2 ln of 2x minus 1 with a range of 2 to 1. Go ahead and solve this. Essentially, we'll get that 15 times 1 by 3 of ln 4 minus 1 by 3 of ln 1, which is just going to be equal to 0. Take away 8 times a half ln of 3 minus a half ln of 1, which again is 0. And this thus simplifies down to 5 ln 4 minus 4 ln 3. And of course, 5 ln 4 can be written as 10 ln 2 because 4 is just 2 to the power 2 minus 4 ln 3, hence solving this question. So for question 7, we've been given a diagram which shows part of the graph y is equal to e to the power minus x squared. And the graph is formed from two convex sections where the gradient is increasing and one concave section where the gradient is decreasing. Now, in 7a, we've been asked to find the values for x for which the graph is concave. So in the question, as the question says, concave is basically where the gradient is decreasing. And for that, essentially, we need to find the values for x for which the double derivative of this graph would be less than 0. So let's go ahead and find that. So if we have y is equal to e to the power minus x squared, essentially we know that dy by dx would just be equal to minus 2x times e to the power minus x squared. Similarly, the double derivative will be obtained using the product rule, where this is just going to be equal to minus 2x times the derivative of e to the power minus x squared, which is just again minus 2x e to the power minus x squared, plus e to the power minus x squared times the derivative of minus 2x, which is just minus 2. And so that then simplifies down to 4x squared e to the power minus x squared minus 2 e to the power minus x squared. So like I said, for concave, we need the double derivative to be less than 0. And so we know that 4x e to the power minus x squared minus 2 e to the power minus x squared must be less than 0. And thus we know that 4x e to the power minus x squared must be less than 2 e to the power minus x squared, where our e to the power minus x squared terms get cancelled out. So we know that 4x must be less than 2, and 4x squared, forgetting the squared term here, and x squared must be less than a half. And if this is the case, essentially we know that x would be between the square root of a half and minus square root of a half. And in proper surd form, this gets converted into minus root 2 upon 2 and root 2 upon 2, hence solving this question. So for question 7b, the finite region bounded by the x-axis and the curve, and the lines x is equal to 0.1 and x equals to 0.5 is shaded below. And we've been asked to use the trapezium rule with 4 strips to find an estimate for the area of the shaded region, giving our answer to 4 decimal places. So we know the trapezium rule to be as follows, where the area is equal to the height by 2 times the addition of the first y plus the last y plus 2 times the addition of the remaining y's. Okay, so in this case, I'm going to choose a height of 0.1. So essentially, my values for x that I'm going to take for my strips is 0.1, 0.2, 0.3, 0.4, and finally 0.5. And we can see that the height of each trapezium would be equal to 0.1. So here I can go ahead and do that, where my height is equal to 0.1 divided by 2, and my first y would be my y when x is equal to 0.1. So I can just go ahead and sub e to the power minus 0.1 squared. My final y would be when x is equal to 0.5. So e to the power minus 0.5 squared would then be my final y term. And then I can go ahead and fill in the rest in a similar way. Where y1 by 0.2, sorry. So e to the power minus 0.2 squared plus e to the power minus 0.3 squared plus e to the power minus 0.4 squared. And then you can go ahead and put this into your calculator, and you should get the value of 0.3611 to 4 decimal places, solving this question. So now in question 7c, we've been asked to explain with reference to our answer in part A, why the answer we found in part B is an underestimate. So in part A, we found that the values for x, which the graph is concave, is given as follows, where it's between minus root 2 by 2 and root 2 by 2. Now, since the region that we're shaded in is within that sort of concave region of the graph, essentially the trapeziums that we had drawn are within the concave region of the graph as well. So that means that they are always going to be an underestimate as they're drawn below the curve. So basically the answer here would be, because shaded region falls within the concave section of the curve, i.e. between root 2 by 2 and minus root 2 by 2, the trapeziums are all underestimates. And that is question 7c. So in question 7d, we've been asked to, by considering the area of a rectangle and using our answer in part B, to prove that the shaded area is 0.4 correct to 1 decimal place. So we can go ahead and try and draw an area of rectangle. So I've gone ahead and already drawn one. So essentially what I did is, if I raise this and sort of do it again, is essentially I took a rectangle which is the same height as the curve, and then this obviously provides an overestimate. So this height of the rectangle here would just be equal to the left-hand side of the rectangle, or the trapezium that we did, which is just y when x is equal to 0.1. And of course, the base of the rectangle would just be the difference between 0.5 and 0.1, which is 0.4. So I know that the area of the rectangle is equal to e to the power of minus 0.1 squared times 0.4. And that is equal to 0.396 when you put this into your calculator. Now, this area of a rectangle is an overestimation, and we have proven that the area under the curve that we calculated in part B was an underestimation. So we know that our actual area lies somewhere between 0.3611 and 0.396. And because it does fall within that region, we can safely say that A would round up to 4. And so we can say that A is thus equal to 0.4 when we round to 1 decimal place, hence solving this question. So in question 8, we have Edna, who wishes to investigate the energy intake from eating out at restaurants for the households in her village. She wants a sample of 100 households, and she has a list of all 2,065 households in the village. Now, Ralph suggests this selection method to first number the households from 0 to 2064 and obtain 100 different 4-digit random numbers between 0 and 2064 and select the corresponding households for inclusion in the investigation. So question 8A has asked us, what is the population for this investigation? So since we are choosing households from 0 to 2064, we know that the list of all the 2,065 households in the village would be our population. So go ahead and circle that as our answer. So now for question 8B, we've been asked, what is the sampling method suggested by Ralph? And this is quite obviously simple, random. So we can go ahead and circle that. So in question 9, a survey has found that of the 2,400 households in Growmore, 1,680 eat homegrown fruits and vegetables. Now in question 9A, we've been asked, using the binomial distribution, find the probability that out of a random sample of 25 households in Growmore, exactly 22 eat homegrown fruit and vegetables. So before we tackle this question, let's find out the probability of success in this distribution. So we know that P would be equal to simply 1680 upon 2,400. And if you put this into your calculator, you should get the answer of 0.7. So now that we have the value of our probability of success, we can go ahead and set up a binomial distribution of X with the sample size of 25 and 0.7 as our probability of success. So now that we can do, we have to find the probability that X is exactly equal to 22. So you can go ahead and use your calculator and you should find the value to be 0.0243. Remember, this is binomial distribution and the sample variables have been given here. So that should be fairly simple for you guys to calculate. So in question 9B, we've been asked to give a reason why you would not expect your calculation in part A to be valid for the 25 households in Gifford Terrace, a residential road in Growmore. And the answer to this is simply the fact that on a residential road, it's unlikely that houses will be independent of each other, which is what binomial requires. So it's unlikely that houses will be independent or different. It's likely that all the houses will be very similar. And so this is why binomial may not be the best method to go for. And that is question 9B. So in question 10, Shona calculated 4 correlation coefficients using data from the large data set. In each case, she calculated the correlation coefficient between the masses of the cars and the CO2 emissions for varying sample sizes. Now, a summary of these calculations labeled A to D are listed in the table below. And as you can see, This is what's been given. Shona would like to use calculation A to test whether there is evidence of positive correlation between mass and CO2 emissions. She finds a critical value for a one-tailed test at the 5% level for a sample of size 3827 is 0.27. So in 10A, first part, we've been asked to state an appropriate hypothesis for Shona to use in a test. Well, she wants to test whether there's evidence of a positive correlation. So suitable initial hypothesis is that of HO is that there is actually no correlation. And then second hypothesis, H1, could be that there is, of course, a positive correlation. So rho would be greater than 0. And she would then have to go and disprove H0 to give some sort of significance to her second hypothesis. So now in question 10A, second part, we've been asked to determine if there is sufficient evidence to reject the null hypothesis, fully justifying our answer. Well, Shona had found that the critical value for the test at 5% significance is 0.027, and the correlation coefficient for A came out to be 0.088. And because 0.088 is greater than 0.027, we would have sufficient evidence to reject the null hypothesis. So essentially our answer is because 0.088 is greater than 0.027, there is sufficient evidence. To reject the null hypothesis. So for question 10B, Shona's teacher tells her to remove calculation D from the table as it is incorrect. And we've been asked to explain how the teacher knew it was incorrect. So if we go ahead and look at the correlation coefficient for D, it's minus 1.183. And it's quite clear why this is incorrect. Well, that's because the correlation coefficient must be between 1 and -1. So that is why the teacher knew it was incorrect. So essentially, the correlation coefficient must be between 1 and -1. And that is our answer. In question 10C, it's been said that before performing calculation B, Shona cleaned the data. She removed all cars from the large data set that had incorrect masses. So we've been asked to use our knowledge of the large data set and explain what was incorrect about the masses which were removed from the calculation. Let's go ahead and look at B. From what we know about the large data set, there are also values of 0. So essentially what Shona must have done is remove those masses which were equal to 0. So essentially, the reason why they were incorrect is because they were 0. Now, question 10D has asked us that apart from CO2 and CO emissions, state one other type of emission that Shona could investigate using the large data set. This is just a general knowledge question. We know that CO2 and CO are definitely types of emissions. Another emission could be particulates or even nitrous oxide. The most common one to use is, of course, nitrous oxide, although you should be able to use particulates as well. And that should yield you the mark. So for question 10E, Wesley claims that calculation C shows that a heavier car causes higher CO2 emissions, and we have to give 2 reasons why Wesley's claim must be incorrect. So our first claim could be that if we look at calculation C, the sample size is really low. So our first point here could be that the sample size is too small to be sure. And secondly, what could be the case is that although it does seem that heavier cars cause higher CO2 emissions, this may not be a direct correlation. At least we cannot prove that. So the correlation could be due to other factors. And this should yield you the 2 marks. So in question 11, Terence owns a local shop. His shop has 3 checkouts, at least one of which is always staffed. Now, a regular customer has observed that the probability distribution for N, i.e. the number of checkouts that are staffed at any given time during the spring, is as follows, where the probability that 1 checkout is staffed or 2 checkouts is staffed is given by this function, and the probability that all 3 are staffed is given by K. So essentially from this information, we need to find the value of K in part A. And we know that since K is equal to the probability of N equaling 3, this can also be equal to 1 minus the probability of the combined probabilities of N equaling 1 and 2. So we can go ahead and write this as such, where it's just going to be N is equal to 1 plus the probability of N equaling 2. So if we go ahead and calculate this, we know that K would be equal to 1 minus 3 by 4 to the 1 by 4 to the 0, plus 3 by 4 times 1 by 4 to the 1. If we go ahead and put this to your calculator, this should come out to be 1 upon 16 for the value of K. The reason that I did this is simply because the probability that all 3 are staffed is 1 minus the probability that only 1 is staffed plus the probability that only 2 are staffed. So that should be very simple, and that is 11A. In question 11B, we've been asked to find the probability that a customer visiting Terence's shop during the spring will find at least 2 checkout staffed. So essentially, we need to find the probability that N is greater than equal to 2. So this would just be the probability of N equaling 2 plus the probability of N equaling 3. So we can go ahead and substitute that in. So essentially, this is just going to be 3 by 4 times 1 by 4 to the power 1 plus K, which is just 3 upon 16 plus 1 upon 16, which is just equal to a quarter. Hence, P of N being greater than or equal to 2 is equal to 0.25. So for question 12, during the 2006 Christmas holiday, John, a maths teacher, realized that he had fallen ill during 65% of the Christmas holidays since he had started teaching. Now, in January 2007, he increased his weekly exercise to try to improve his health. For the next 7 years, he only fell ill during 2 Christmas holidays. So in question 12A, we've been asked to use binomial distribution and investigate at a 5% level of significance whether there is evidence that John's rate of illness during the Christmas holidays had decreased since increasing his weekly exercise. So here, what we can do is determine a variable X, which is the number of holidays without illness since January 2007. So once we define this, what we can do is then carry out the binomial distribution of this. So X to B would be between the time span of 7 and then the probability of falling ill, which would be P. Now, our initial hypothesis here should be that, indeed, the null hypothesis should be that P is equal to 0.65. So essentially, we're assuming that there is no decrease or increase in the rate of his illness. And then our first hypothesis, H1, would be such that P is less than 0.65. So now we can go ahead and calculate the probability of X being less than equal to 2. If we go ahead and use our calculators to solve this, we should get that P of X being less than equal to 2 is equal to 0.0556. And this is clearly above 5%. So because this is clearly above 5%, HO is accepted. and thus there is not significant evidence that his rate of illness has actually decreased. We can write a conclusion here, thus no significant evidence that his rate of illness decreased. And that is question 12A. So for question 12B, we've been asked to state two assumptions regarding illness during the Christmas holidays that are necessary for the distribution that we've used in part A to be valid. Now, for each assumption, we have been asked to comment within context on whether it is likely to be correct. Now, one assumption that we can make here is that the probability of illness remains constant. Okay, that's our first assumption. Now, is that valid? Well, not necessarily. Not necessarily. Why? Well, because as you may know, age does have an effect on the human immune system. So this may not necessarily always be constant. So it's not necessarily valid as age has an effect. Okay, now our second assumption could be the fact that this model does sort of assume that there's only two states of well-being, either you're ill or you're not ill. So we can go ahead and assume that there's two states, i.e. ill or well. And is this valid? Well, that's sort of unclear. Why? Because how sort of do you define whether you're ill? Does a sore throat count? Does having a minor cough count? Stuff like that. It's a really gray area. So we can go ahead and say that this is really unclear, as you need to decide what being ill actually means. Okay, and they are two fairly valid assumptions that we've made during the study, and this is thus 12. So in question 13, in the southwestern region of England, 100 households were randomly selected, and for each household, the weekly expenditure X pounds per person on food and drink was recorded. The maximum amount recorded was £40.48, and the minimum amount recorded was £22. The results are summarized below, where X bar denotes the sample mean. Now, in question 13A, we've been asked to first find the mean and standard deviation. So this is fairly simple. We know that the mean of X is just equal to the sum of X upon the number N. The number of households that have been included in the study. And this is just equal to 3046.14 by 100. And this is just equal to 30.46. Now, for our standard deviation, this would just be the sum of X minus X bar squared upon N. So this would just be equal to 1746.29 upon 100, which is 4.179. Now, I know the mark scheme says that this should be 99, but 100 is a perfectly valid answer, so you should have no problems. In the second part for 13A, we've been asked to use our results in part A1 and any other information given to explain why the normal distribution can be used to model X. So if we go ahead and look at the piece of information, we know that the maximum value recorded was £40.48 and the minimum was 22. Now we know that normal distribution can work within values of X plus minus 3S. And so if you go ahead and calculate what these are, this is just going to be, so X bar plus 3S would just be equal to 30.46 plus 3 into 4.179, which is equal to around 43. And then X bar minus 3S would be equal to 30.46 minus 3 upon 4.179, which is roughly around 18. Now, since our answers, or sorry, our amounts recorded fall between that sort of range, we know that this normal distribution can be used, especially since the data can be regarded as continuous. So two reasons is it's continuous data and also falls between x bar plus minus 3s, and that should be sufficient to gain the marks in this question. For question 13A3, we've been asked to find the probability that a household in the Southwest spends less than £25 on food and drink per person per week. So essentially, we have to find the probability that X is less than 25. Go ahead and use normal distribution on your calculator, and this should be equal to 0.0967. For question 13B, we've been given that for households in the northwest of England, the weekly expenditure Y pounds per person on food and drink can be modelled by the normal distribution with mean £29.55. It is known that the probability of Y being less than 30 is 55%. So we have to now find the standard deviation of Y, giving our answer to one decimal place. So essentially, we know that the probability of Z being less than 30 minus 29.55 upon sigma would thus be equal to 0.55. And essentially from this, we can go ahead and find our value of Z from our calculator. So Z from the normal distribution in our calculator would be somewhat equal to 0.1257. So once we have that value from our calculator, we can go ahead and use our normal model to form an equation such that we know that 30 minus 29.55 upon sigma would be equal to our Z. And thus we know that 30 minus 29.55 upon sigma would be equal to 0.1257. If we rearrange, we should find that sigma is equal to 30 minus 29.55 upon 0.1257. And this then equates to 3.6. And hence we have found the standard deviation to be 3.6. So in question 14, a survey during 2013 investigated mean expenditure on bread and on alcohol. The 2013 survey obtained information from 12,144 adults, and the survey revealed that the mean expenditure per adult per week on bread was 127p. Now in 14A, it's been given that for 2012, it is known that the expenditure per adult per week on bread had mean 123p and a standard deviation of 70p. Now, in 14AI, we've been asked to carry out an hypothesis test at the 5% significance level to investigate whether the mean expenditure per adult per week on bread changed from 2012 to 2013. So we've also been asked to assume that the survey data is random and taken from a normal distribution. So to attack this question, we have to realize that this is going to be a two-tailed test. Why? Because we are surveying a change from one year to another. So we have two distributions, one where X is normally distributed with mean mu and variance sigma squared, and also the sample mean, which is going to be X bar. This is again normally distributed with mu, but this time the variance is going to be sigma squared by n. So our null hypothesis here is going to be that our mean remains 123. So mu is essentially equal to 123 is our null hypothesis. H1 would then thus be that mu is not equal to 123. Okay, so now that we have this, we can go ahead and calculate our value for standard deviation. And for this, we need to know that sigma squared upon n would be equal to 70 squared upon 12144. And then this means that for X bar, sigma would be equal to the square root of 70 upon 12144, as we're equating the variance on this distribution and this distribution. So go ahead and put this into your calculator and you should get 0.6352. Okay, so now that we have these sort of values, what we can go ahead and do is sort of graph out our distribution. So I'm going to go ahead and do that. So since this is two-tail, essentially it will look like this, where we have one tail on this side, one tail on this side, and this tail was 0.025, so 2.5% here and 2.5% on the right hand side. So 1 minus 2.5% is just 0.975. So essentially now what we can do is see if our normal distribution occurs outside of our tails or inside of our tails. And so if we go ahead and do a normal CD on our calculators with the following parameters, where our lower limit is equal to, say, a really low number like minus 100, and our upper limit is set to 127. Our sigma here is what we calculated before, so 0.6352, and our mu is just going to be equal to 123. So if I go ahead and calculate this, this comes out to be equal to 0.9999. And since 0.9999 is much greater, or not much greater, sorry, is greater than 0.975, it occurs somewhere here in this tail. So 0.999 will be here. HO is rejected. And thus, there's evidence that prices changed from 2012 to 2013. And that is thus this part complete. So for 14A, we've been asked to calculate the greatest and least values for the sample mean expenditure on bread per adult per week for 2013 that would have resulted in acceptance of the null hypothesis for the test you carried out in part AI. So we have to give our answer in 2 decimal places. So what we can do is take our lowest value here, and essentially we can go ahead and use our inverse normal method. So we know that our inverse normal method here, or inverse normal area, would be equal to the sort of lower tail that we took in the previous part, which is 0.025. Our sigma would be what we calculated to be 0.6352, and our mean would be, sorry, our mu would be 123. So in this case, if we go ahead and calculate this, X bar comes out to be 121.76. For our higher limit, we know that our inverse normal area is equal to 0.975. Sigma is the same at 0.6352, and mu stays the same again at 123. And this yields us X bar as equal to 124.25. And that is this question. So question 14B has given that the 2013 survey revealed that the mean expenditure per adult per week on alcohol was 324p. The mean expenditure per adult per week on alcohol for 2009 was 307p. A test was carried out on the following hypotheses relating to mean expenditure per adult per week on alcohol in 2013, where our null hypothesis was mu is equal to 307. And H1 was that mu is not equal to 307. This test resulted in the null hypothesis being rejected. Now, we have been asked to state with reasons whether the test result supports the following statement. So our first statement is that the mean expenditure on alcohol per adult per week increased from 17p from 2009 to 2013. Now, this is not supported. Why? Because all that this test does suggest is that the mean expenditure had changed, but it does not specify an amount. So our answer here is not supported. Test suggests expenditure changed, but no indication of a specific amount. Okay, so that is this part. Our second statement is that we're supposed to use the test to state whether the mean UK consumption of alcohol per adult changed from 2009 to 2013. Now, the tests only indicate that expenditure increased, but that may not necessarily correlate to consumption. Expenditure may also have increased if, for example, the price of alcohol went up. So essentially, we can go ahead and conclude that this is not supported again, because while test suggests that expenditure increased, this may not be due to consumption increase. So i.e. the price of alcohol might have gone up, for example. Okay, so that is this part done as well. So in question 15, a sample of 200 households was obtained from a small town. Each household was asked to complete a questionnaire about their purchases of takeaway food. Now, A is the event that the household regularly purchased Indian takeaway food, and B is the event that a household regularly purchased Chinese takeaway food. It was observed that the probability of B given A is 0.25, and the probability of A given B is 0.1. And of these households, 122 indicated that they did not regularly purchase Indian or Chinese takeaway food. A household is selected at random from the sample, so we need to find out the probability that the household regularly purchases both Indian and Chinese takeaway food. So essentially, we need to find the probability of A and B. So let's go ahead and use this information to possibly produce a Venn diagram to help us. So if I go ahead and produce a Venn diagram here, with this being A, this being B, I can go ahead and use the fact that B given A is equal to 0.25. So essentially, I know that if B given A is 0.25, then it could essentially look like this, where the sort of where the probability of a house purchasing both Indian and Chinese would be X, and X divided by 4X is of course 0.25, and this is B given A. Now A given B is 0.1, so that means that this here would be 9X, because now X divided by 10X is of course 0.1. And we have 122 households who've indicated they don't regularly purchase either. So from this, we know that the total sample was 200. So we can go ahead and create a balance here. So we know that 9x plus 3x plus 122 is equal to 200. And this gives us 13x plus 122 is equal to 200. 13x is thus equal to 78. And thus we get x is equal to 6. So now that we have our value for x, we need to find the probability of A and B, which is just x from the diagram. So we know that the probability of A and B is just equal to 6 by 200, or 3 by 100 if you want to round. And that concludes this question.